All right, let's talk about something that sounds like it's straight out of science fiction. Can we actually teach our own lungs to heal themselves? We usually think of serious organ damage as a one-way street, but a pretty amazing discovery from the Mayo Clinic is suggesting that might not be true for much longer. I mean, think about it. For millions and millions of people all over the world who are living with chronic lung disease, this isn't just some interesting science question. It's their daily reality. Once that delicate lung tissue is scarred and damaged, is that it? Is it really the end of the story? For the longest time, the medical world has pretty much had to say, yes, that damage is permanent. But something is starting to shift. There's this new hope on the horizon that suggests we might finally be able to rewrite that ending. So to really appreciate why this new discovery is such a huge deal, we've got to look at where things stand right now. What can medicine actually do for damaged lungs today? The hard truth is that our best treatments for diseases like COPD or pulmonary fibrosis are all about management. They can slow things down, sure, they can help with symptoms and make life better, but they can't turn back the clock on the actual physical damage. It's all about playing defense, not actually regenerating the tissue. But what if we could finally go on the offense? This is where the story gets really exciting. It's all about the discovery of what you can basically think of as a hidden on switch for lung repair. So, in a study that was published in Nature Communications, researchers over at the Mayo Clinic zeroed in on the exact molecular process that tells our lung cells when to fight an infection and when to rebuild. This is just a fundamental discovery about how our own bodies work. And this quote right here just perfectly sums up the potential. We're talking about shifting the entire conversation from just slowing down damage to actually reversing it. That's not a small step, folks. That's a giant leap into a whole new way of thinking about chronic diseases. Okay, so how in the world does this molecular switch actually work? Well, to get that, you need to meet the lung's own master repair crew. Let me introduce you to the heroes of our story, the alveolar type 2 cells, or just AT2 cells for short. Think of these guys as the lung's personal on-call stem cells. Whenever there's damage, they're the ones who get the call to come in and rebuild those tiny, delicate air sacs where all the magic of oxygen exchange happens. Now, what's so wild about these A2 cells is that they're moonlighting. They have two totally different jobs. They can either be in infection-fighting mode, kind of like a security guard, or they can be in tissue repair mode, like a construction crew. But here's the catch. They can't do both jobs at the exact same time. It's one or the other. So what decides which job the cell is doing? Well, the researchers found this one specific protein called TMEM100, and they gave it the perfect name for what it does. They call it the repressive clamp. It's basically the molecular boss that decides the cell's entire job description for the day. So when that TMEM100 clamp is on or active, it basically locks the AT2 cells into their defensive, infection-fighting mode. And while they're doing that, their ability to regenerate tissue is completely shut down. And it looks like in a lot of chronic diseases, these cells get stuck with the clamp on, which means no real repair can ever even get started. Okay, so if the whole problem is a stuck clamp, then the solution becomes almost beautifully simple, right? We just have to figure out how to release it. And that simple idea could unlock an entirely new form of therapy.
This discovery basically hands us a perfectly logical roadmap for a brand new kind of treatment. Step 1, you find the cells that are stuck. Step 2, you figure out a way to target that TMHM100 clamp. Step 3, you release it, and then you just let the cells do what they were born to do, repair stuff. And the final, incredible goal, to actually restore lung function.
And this is not just a cool idea. The research team is literally working on this as we speak. The big goal here is to take human AT2 cells, take that clamp off in the lab to basically supercharge their healing powers, and then use those very cells in replacement therapies to rebuild damaged lungs from the inside out. The ability to control this switch is it's massive. And the implications go way, way beyond just creating a single new treatment. When you step back, you see this one discovery opens up so many doors. I mean, beyond the incredible potential to reverse damage, it could also help us figure out how to detect when these cells get stuck way earlier. That could let doctors step in before a ton of damage even happens. It really does change our entire approach to how we think about organ repair.
It's also important to know that this research isn't just happening in some isolated lab. It's a key piece of these much larger initiatives at the Mayo Clinic that are focused on what is basically the holy grail of regenerative medicine, preventing organ failure in the first place, and if it does happen, finding a way to actively restore its function.
And that, of course, leaves us with this one last, absolutely tantalizing question. The lungs have their AT2 cells with this molecular clamp. So it stands to reason that other organs probably have their own unique repair crews with their own on-off switches, right? If we can learn how to release the clamp in the lungs, what's next? The liver, the kidneys, the heart? This discovery might have just given us the master key.